Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore how a distant planet nearly 80 light-years away survived the violent death of its own star, defying what scientists thought was possible. The discovery is offering scientists a rare glimpse into what happens to planetary systems long after their stars reach the end of their lives. When a star dies, it does not go quietly. A sun-like star in its final phase swells into a red giant, expanding to hundreds of times its original size and incinerating everything in its inner system. Then it sheds its outer layers entirely, leaving behind a white dwarf, a dense, Earth-sized remnant of the original star, cooling slowly over billions of years. Any planet that was close enough to be engulfed by the red giant is gone. The conventional wisdom was that whatever survived a star's death must have been far enough away to escape that expansion. Then astronomers found WD 1856b, a planet as large as Jupiter, orbiting its dead white dwarf host every 34 hours at a distance of less than 1,864,113 miles. And the conventional wisdom needed revising. WD 1856b was first detected in 2020 using NASA's Transiting Exoplanet Survey satellite and the Spitzer Space Telescope. Even then, the discovery was deeply puzzling. The planet is enormous, between 4 and 11 times the mass of Jupiter, with a radius roughly 8 times that of its white dwarf host, which is only about the size of Earth. When it transits in front of the dead star, it blocks a staggering 56% of the star's light, one of the highest transit depths ever recorded. And it is orbiting at an extraordinarily tight distance, less than 3 million kilometers from the white dwarf, completing a full orbit in just 1.4 days. The immediate question was how a planet that large could be orbiting that close to a star that had, billions of years ago, expanded into a red giant large enough to have destroyed anything in that region. A new study published in the journal Nature on July 1, 2026, has used the James Webb Space Telescope to analyze WD 1856b's atmosphere for the first time, providing the data needed to finally understand the planet's history. The research team, led by Christopher O'Connor of Northwestern University's Center for Interdisciplinary Exploration and Research in Astrophysics and Ryan J. MacDonald of the University of St Andrews in Scotland, found that WD 1856b's atmospheric chemistry, mass, and thermal properties tell a specific story, one that was not what most astronomers expected. The key finding of the 2026 study overturns the most intuitive explanation for WD 1856b's presence. The planet did not survive the red giant phase by being close to the star. It was not there during the red giant phase at all. Instead, WD 1856b originally orbited its host star from a much greater distance, far enough to be safe when the star expanded and died. It was only afterwards, between 3 and 5.5 billion years after the white dwarf formed, that the planet gradually migrated inward to its current orbit through gravitational interactions with other objects in the system. The planet did not outlast the star's death. It moved in after the worst was already over. One of the clues that pointed researchers toward the migration theory is WD 1856b's temperature. The planet registers at around 400 Kelvin, warmer than it should be given its distance from a cooling white dwarf that generates very little heat. The explanation lies in the physics of orbital migration. As the planet spiraled inward over billions of years, tidal forces, the same gravitational stretching that makes Earth's oceans bulge toward the moon, generated heat inside the planet's interior. That residual tidal heating is still warming WD 1856b today, producing a thermal signature that the James Webb Space Telescope could detect and that matched the migration timeline. The Sun will run out of fuel and begin its red giant phase in approximately 5 billion years. When it does, Mercury, Venus, and Earth will almost certainly be consumed. Jupiter and Saturn, orbiting much farther out, will likely survive the expansion. What WD 1856b demonstrates is what could happen next. After the Sun collapses into a white dwarf, the surviving outer planets may not simply continue orbiting as they do today. Gravitational dynamics could cause them to migrate inward over billions of subsequent years, eventually ending up in orbits far closer to the white dwarf remnant than they occupy today, just as WD 1856b did. The solar system's final chapter, it turns out, may look considerably more eventful than a quiet, slow cool. Beyond the fate of our own solar system, WD 1856b matters because it is the first confirmed giant planet orbiting a white dwarf for which a detailed atmospheric and thermal analysis has been possible. White dwarfs are abundant. The vast majority of Sun-like stars in the galaxy will eventually become them. But the planetary systems surrounding them have been difficult to study. WD 1856b, at 80 light-years from Earth and with its dramatic 56% transit depth, offers the clearest view yet of what those post-stellar systems look like and how they evolve. The James Webb Space Telescope, with its ability to analyze planetary atmospheres in unprecedented detail, is expected to find more systems like it, giving astronomers a growing catalogue of planets that survived or arrived after the deaths of their stars. Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.